Finding intersection between a matrix and a vector, by row. Consider the following. Yields a matrix. Now, I want to know the sum of values in each row that intersects a vector. Say, returns. This is the desired output. The problem with it is that my matrix is almost equal to 1,000,000 x 2200, and I have 6700 vectors to compare against. The solution I have here is far too slow to attempt. How can I improve what I'm doing? It's worth noting that the values inside of the matrix come from a set of 30,000 values, and I have the full set. I've considered solutions where I make a dict of these 30,000 values against each vector, and use the dict to convert to true/false throughout the matrix before just summing by row. I'm not sure if this will help.
For matrix and vectors arrays, here's one with np.search sorted. With a comparatively smaller vec, we can pre-sort it and use, to give us an alternative one to compute the row counts, like so. The above solutions works on generic inputs, numbers or strings alike. To solve our specific case of strings, we could optimize it further by converting the strings to numbers by using np.unique and then reusing count_in_rowwise count_in_rowwise_v2, and that will give us our second approach, like so.
You could use set intersection to speed things up a bit. Here's a comparison. Your present solution with list comprehensions. Proposed solution with set intersection in list comprehension. And if the vec is also a set, we get even better efficiency.
Here's a simple readable solution with np.isint docs. As a bonus, you can just use np.isint without the summing if you want to get which elements of the matrix are in the vectors. Which shows why summing along the rows produces the desired output.
Let's look at the speed of your current algorithm. According to the Python wiki, checking if an item is in an array like y in vec is O(n), meaning worst case, it has to go through every element in vec. Since you're doing that check for every element of your matrix, your total number of operations is numRows *numpls *veclin, which is O(n) cubed. A faster way to do it is to construct a dictionary for vec to optimize lookups, because dictionaries are O(1) instead of O(n), meaning they can do your check in one operation, no matter how long vec is. So, your new time complexity is numRows *numpls plus veclin, which is O(n², which I think is as fast as you can get for your data.